My name is Mariana, and welcome to our demo, Mobility Stream Processing on Nebula Stream and MIOS. The goal is to run real-time spatial-temporal analysis from streaming data on a highly distributed IoT network. The problem is that stream processing IoT systems lack spatial-temporal processing capabilities. Also, spatial-temporal libraries focus on historical data. The solution is to integrate MIOS, a spatial temporal processing library, to Nebula Stream, data management system for the IoT. This scenario focuses on train operations, where continuous data is collected from moving trains. We observe parameters such as location, noise level, or brake pressure. The primary objective is to detect important events and to react properly immediately. This is the architecture of the train. So the train has many sensors, such as brake, and they send their measurement to a central edge device. Right now, what the company is doing is to compute this measurement in the server after the data is sent. What we are proposing is to process on edge where the data is measured. With this processing, we can alert maintenance immediately if they need to address some issue with the train, or we can also reduce the data stream by cleaning data with multiple alerts. We also do not need to rely on network connection as the processing is done on edge. Intended user is transportation operators, logistic managers, or any organization that needs real-time geospatial awareness. We also think of data scientists as the system is not bound to train data, it is general mobility streaming system. The system components, we have Nebula Stream. Nebula Stream processes large-scale streaming data with low latency, making it suitable for scenarios like sensor network and IoT applications. MIOS implements structures with spatial temporal types and functions, allowing complex queries over moving objects. We present now our system architecture. We have data coming from multiple sensors in the train GPS, for example, and they arrive via a streaming pipeline. Nebula Stream processes these streams in real time, while MIOS handle the streaming and temporal aspects of this incoming data. We talk now about the visualization. We offer visualization that allows users to assess the challenges of train operations and also see analysis that could be done with Nebula Stream system. So now we present the interface that viewers can choose between all 8 queries. For example, we can choose the alert filtering query. This query filters out alerts when a train is inside a workshop because tests are done and sometimes the speed limit, for example, is over what it should be, and we don't want maintenance to go looking for a train that is already in a workshop. We can also look for the noise. So here we are trying to see how much the train impacts a neighborhood. We can choose here for this train, which is train 3. We can see the noise level here, and we can see how much it affects. We can also check for the speed limit. We want to see if a train has gone over the speed limit in a risky zone. So here we determine this is a risky zone, and we see that this train has gone over the speed limit, and we emit high speed warnings. We also want to see how much the weather affects the speed of the train. So what we have here is we can choose for snowfall or precipitation, and we can see if the train is in a high precipitation zone, and then we determine that the train should slow down. We also check for the battery monitoring. So what we want to see is to see if the battery is decreasing inside the workshop, because sometimes they use battery and the train will not start over again if the battery is too low. Another thing we want to see if the train has too many passengers, because then we can determine that if the passenger load is too much, next time they will put another train in this route. We can also monitor brakes to see if they are decreasing. What we can do here is to check for a specific train. So for example, let's choose for train 3. We want to see if the brake is fine or not. If it's not, so for example, here we have one of the pressures is too high and the other is too low, we send an alert because they should check if the brake is healthy or not. Last one, we choose if the stops, we determine if the train is stopped in somewhere else other than the station or a workshop. because if the train has stopped elsewhere, they probably need maintenance help. So thank you so much for your attention.